Hello class, in this video we're going to be looking at the different types of intermolecular forces. We've already talked about what an intermolecular force is. In this video we're going to want to look at, well, what causes this intermolecular force to actually happen. First, we just want to review, they're actually strong enough to control the physical properties that these intermolecular forces are. Such as boiling point, melting point, vapor pressures, and viscosities. These intermolecular forces as a group, we refer to them as van der Waal forces. So the three types of van der Waal forces that we're going to be looking at are the dipole-dipole interactions, hydrogen bonding, which is just a specific type of dipole-dipole interaction, and then London dispersion forces. So these are the three types that we're going to be looking at. The first one I kind of want to look at is this dipole-dipole interaction. And a dipole is just molecules that have that are polar, and they have this permanent dipole. That just means that they have one side that is slightly positive, one side that is slightly negative. We saw this in an earlier chapter. We know that it's a polar molecule is caused because one side of the atom is more electronegative than the other atom in that molecule and has more of the electrons on its particular side, causing a slightly negative charge on that side and a slightly positive charge on the other side of that molecule. Even though the overall charge is neutral, meaning that we have the same number of protons as electrons, where they are placed in the molecule gives this dipole moment, this polar molecule. And in dipole interactions, we have the positive side attracted to the negative side of another molecule. These forces are only important when the molecules are close together, like in liquids and in solids. So here's a diagram of a dipole-dipole interactions, and what we should want to look at is that the positive side of this polar molecule is attracted to the negative side here, and vice versa. This negative side is repelling the other negative side of the other molecule, and they start to form these bonds between opposite charges, and that's what this dipole-dipole interaction is. And what we see then is that the more polar the molecule, the higher the boiling point. So if we look at the dipole moments, that's just measuring how polar is this particular molecule. As that goes up, the boiling point goes up, because it's the more polar, the stronger that intermolecular bond is, the harder it is to break it and then boil that substance. So the next type of force that I want to kind of talk about is this London dispersion force. And we're usually going to talk about this with a nonpolar molecule. The nonpolar molecule doesn't have a dipole, but it may have an instantaneous dipole. So what does that mean? So what that means is that these electrons are moving around the atom, and at a very small instance they may be on the same side of the atom, making the atom kind of look polar, because the electrons just so happen to be on this side of the atom, giving it a dipole, a positive side and a negative side. Then if we bring that atom in close to another nonpolar atom, we can induce a dipole on this second atom, where when we bring this atom closer, the electrons are repelled further away, causing a dipole on this secondary atom, and then this attraction here will occur between the negative side of one atom and the positive side of a different atom. So London dispersion forces, or just dispersion forces, are attractions between an instantaneous dipole and an induced dipole. So these forces are present in all molecules, whether they are polar or nonpolar, but we're really going to look at them in the nonpolar molecules. And the tendency of an electron cloud to distort in this way or become polar is its polarizability. So how polar can we make that atom? The more polar we can, the higher polarizability that atom has. So the shape affects this dispersion force. So long, skinny molecules like this one here, with a lot of surface area, we can move the electrons easier to one side, making this atom polar. If you have short, fat, round molecules, it's harder to move the electrons to the other side, and this is it's harder to make this particular molecule a polar molecule or act like a polar molecule. Also, the strength of the dispersion forces tend to increase with the molecular weight. So if we look at the molecular weight here, the boiling points go up, and the reason why is because the intermolecular forces are stronger. This dispersion force is stronger, and it's able to hold the molecules closer together. The larger the atom, the larger the electron clouds, which are easier to polarize. The bigger the electron cloud, the more we can push the electrons on the other side of the atom, and the bigger dipole we can induce. So the last type of van der Waals force I want to kind of talk about is hydrogen bonding. Now, hydrogen bonding is a very specific type of dipole-dipole interaction where we have a hydrogen bonded either to nitrogen, oxygen, or fluorine, and this is going to be a very unusually strong type of bond, this hydrogen bonding. So you can see some examples on this side here, but I want to look at a water molecule, or a couple of water molecules. So if we look at this hydrogen here in this diagram, it's covalently bonded to its oxygen here, but it also has this hydrogen bond, this attraction to this oxygen of a different water molecule. Because of the high electronegativities of nitrogen, oxygen, and fluorine, the hydrogen nucleus is exposed, and this is what's going to cause that big attraction to another polar molecule. So the last type of force I kind of want to talk about is this ion-dipole interaction. And the reason why I want to kind of talk about this is why ionic substances dissolve in polar solvents. So if you put salt into water, this is why it dissolves, is because the polar side of the molecule, the negative side of the molecule, is attracted to the positive ion in the ionic substance, and the positive side of the polar molecule is attracted to the negative, and it kind of separates these different ions and kind of surrounds them, and that's how ions are dissolved in polar solvents. So that's the end of the video. Hopefully we learned the different types of intermolecular forces, how they're caused, and what affects the strength of an intermolecular force. If you do have any questions, please bring them to class as always.